Alright, so the purpose of this video is enantiomers, drawing and naming enantiomers, and I'm going to be a bit brief about it just because it's we can talk about this for a long time. First thing I'm going to do is I'm going to say, let's use an example of this, and let's say that let's name this first of all. This is going to be 1, 2, 3, 4 butane. Identify the substituents, chloro. There's my butane right there. Okay, identify the substituents, chloro. And now we've got to say where it is. 1, 2. It's 2-chlorobutane. Okay, let me redraw it again to make it sort of clean. Alright, now that is 2-chlorobutane. There's obviously another hydrogen on here. And the question is that hydrogen coming out toward us or is it behind us? And sometimes it doesn't matter. Let's put the chloro here. Okay. Sometimes it doesn't matter, but it does matter if this is an asymmetric center. So what I said in a previous video was this is an asymmetric center if there are 4 unique things coming off of this carbon. Okay. So what's off this carbon? It's a methyl group. This is chloro. This is a hydrogen. And this is an ethyl group. So indeed, this is an asymmetric center. Alright, if it's asymmetric, then we've got to describe its absolute orientation, which this doesn't do because I didn't use 3-dimensional notation here. But I did use 3-dimensional notation here. So to call this chlorobutane is not good enough. We've got to say if it's chlorobutane in the R configuration or the S configuration, which I haven't even defined yet, right? Okay. So in order to do that, what we're going to do is we're going to go through the carbon here, and we're going to identify the substituents, and then we're going to prioritize them. And the way we prioritize them, simplest case scenario, is we just get the atomic number of the closest atom. So that's atomic number 1. That's the least priority. The highest priority is going to be chlorine because these are both carbons. Okay. So I'm going to call that priority 1, and this is priority 2. And this is priority 3 because this has a carbon on it, that has a carbon on it. This has got a carbon, and then it's got a carbon and 2 hydrogens. This has got 3 hydrogens on it. So this is a higher priority than that. You might also sort of approximate it by looking at the molecular weight. There's some times when that sort of breaks down, but it sort of tracks with molecular weight. So this is the biggest one. That's the next biggest. This is top priority, I should say. Then that, and then this is number 4. Okay. So rule number 1 is you identify the substituents. Rule 2 is you rank them in terms of priority. We'll say more about priority later. And number 3 is we put priority number 4 in the back, which is already in the back here. And rule number next is you draw an arrow from 1 to 2 to 3. If it's clockwise, it's R. If it's counterclockwise, it's S. All right. So this is 2R. 2-chlorobutane. Let me do another example. Well, let's use this as an example. This is, of course, has the same priorities. This is still 4. This is still 1. This is 2. And this is 3. But you notice that 4 is not in the back. So what I'm going to do, when I'm doing this, and we already know it's S because this up here was R. But what I'm going to do, whenever I see something like this, suppose we had not just named that, can you see that these are mirror images of each other? Okay. So I'm going to take this and I'm going to redraw it, putting the lowest priority one in the back, knowing that this is not the same thing as this over here. This is the mirror image of it. But since I've got the mirror image and I've got this in back, it'll be easier for me. 1, 4, 2, 3, right? Now I'm going to go 1, 2, 3. Okay? This is R, and therefore this must be S. Okay? And I'm doing that because it's easier for me to see. Now, it's a lot of work to draw this other structure and to name it and so on, but it's just so easy for me to get backwards if I don't somehow manually make notes for myself like that. So this is S because its mirror image was R. All right, let me do one more example, and then I'll give you a question. Okay, let's do chlorine here. Or rather, let's do this. Okay, so this guy does not have 3 separate things on it. Oh, we're never going to be able to name this because it's a ketone and an alcohol and so on. But let's find out if it's our S configuration. CH3, that is not an asymmetric center. This is an asymmetric center. Sure it is, because it's got a methyl group on it. It's got this mess over here, and then it's got a hydrogen and a hydroxyl. All right, so this is an asymmetric center. I'm going to put a asterisk there. This is an asymmetric center, right? Wow, this is too complicated. All right, that's not, because it doesn't have 4 things on it, and that's not. So both of these are asymmetric centers. All right, so I'm going to do this first one. I'm going to redraw it so I don't get all boogered up. Okay, let's talk about this one first. It's got a methyl group on it, a hydroxyl, a hydrogen, and this other mess. Okay, so let's go out. First of all, the first carbon out's a carbon over here. The first carbon out's a carbon over here, and this is hydrogen. It's going to be last. That's going to be number 4. But this first atom out's on oxygen, so that's going to be priority 1. Carbon, carbon, hydrogen, oxygen. It's priority 1. Now this one over here, it's got a carbon and 3 hydrogens coming off of it. This has got a carbon and some other things coming off of it. So this is definitely going to be priority 2, and this will be priority 1. Okay. Now I never said if that hydrogen was going back or not. Crud. I ruined this video, didn't I? By not saying if that was going back. Let's say it's going back. Okay, so it's over here. It doesn't matter if it's, it's right. It's there. And this guy's coming out toward us. Okay, number 4 is in back, so we don't even need to see it anymore because it's already in back, right? I admit I changed that in the middle of the story. Okay, now we see. Oops, I said that was 1. This is going to be 3, right? Because that's number 2. 1, 2, 3. Okay, this is R. I'm going to redraw it because I'm going to get lost if I don't. That's R. Alright, now let's do the same thing here. Let's say that the hydrogen in back and the chlorine's in front. If it's R, it's going to seem like a big coincidence, but alright, so the hydrogen is always priority number 4. Chlorine, carbon, and carbon. This is definitely number 1 because chlorine is bigger than carbon and carbon. And this carbon has got 2 oxygen bonds going to it, and this only has 1. So this is 2. And this is 3. Alright, so 1, 2, 3. This is S. Alright, so what we have is some big long name because it's a ketone and an alcohol and an alkyl halide all in the same structure, but it's going to be 2S, or rather we're going to be coming from this side. Whatever this is, it's going to be S, and that's going to, or R, and that's going to be S. Alright, I think I'm going to have to redo that video and come up with a better example. In the meantime, I'm going to post this one. Good luck.